Hi guys, I'm Olivia. I'm a maths tutor here at ACE, and today I'm going to be going through with you a Year 12 advanced question from the HSC. And what this question is asking us to do is to differentiate and then hence integrate, which is a topic within calculus that advanced students tend to find a bit more tricky. So first of all, we want to find the derivative of x squared tan x. Okay, so when we're differentiating something that is like a compound function like this, we typically want to be using the product rule. So in this case, our u is going to be x squared and our v is going to be tan x. So we'll differentiate each of these individually and then combine to get our overall derivative. So our u dash is going to be the derivative of x squared, which is 2x, and our v dash is our derivative of tan x, which is sec squared. So then combining that together, the derivative of our entire function x squared tan x is going to be u dash v plus v dash u. So that's 2x times tan x plus v dash u, so plus x squared times sec squared x. Part B, we are asked to find the integral of x tan x plus 1 or square. And so we know that because it's a hence question, we're going to be directly using something that we found in part A to solve this question. However, the problem is that it's sort of not immediately clear what that's going to be, right? So what we're going to do, first of all, is we'll probably just expand it out and then see what we can do from there. So this is equal to the integral, and so we'll do expansion over perfect square, x squared tan squared x plus 2x tan x plus 1 dx. Okay, and this is looking a lot more promising now because we have the 2x tan x, which is directly a term from part A. However, the x squared tan squared x is a little bit more difficult because we don't have a tan squared term. However, what we're going to need to remember to do this question is we're going to use the identity that 1 plus tan squared x equals sec squared x, right? So we can either substitute that into our expression from part A or from part B. I might do from part B. So this means that our integral is equal to the integral of x squared times sec squared x minus 1 plus 2x tan x plus 1 dx. Okay, so then simplifying that, that's x squared sec squared x minus x squared plus 2x tan x plus 1 dx. Okay, and then if we look at these terms, we can see that we have the x squared sec squared x and also the 2x tan x, which make up our entire term from part A. So what we want to do is we can separate our integral out. So we have the integral of 2x tan x plus x squared sec squared x dx plus the integral of negative x squared plus 1 dx. So that's just separating out the integral by addition, okay? And then we can solve each of these. So for the first part, the key insight that we want to be using is that if you differentiate a function, right, to get a new function, if you want to integrate that new function, that's just going to give you back the original function. So when we're integrating 2x tan x plus x squared sec squared x, that is our original function from part A, right? So it's just going to be x squared tan x. Then for the second part, we just want to simply integrate negative x squared and 1. So negative x squared is going to be using our reverse power rule, I guess. So we'll add 1 to the power x cubed and then divide by 3. So we get negative x cubed on 3, and then 1 is just a constant, so it's going to just become x. And last of all, never forget to include our plus c term. So that will be our answer for part B of this question. If you guys are looking to sit HSC Maths Advanced in the next couple years, have a look and join our Maths Advanced program here at ACE HSC.